Hello, everybody, and welcome back to the Azure podcast. Today is November 9th, and we are recording episode number 446. And we have Abhishek back for his fourth time. Tiwari back for the fourth time today. He's going to talk about networking edge and layer 7 security. So a slight pivot to some of the stuff we talked about in the past, but I'm sure, as always, he's going to be a great guest. Before we get to Abhishek, Kendall, Sujit, what do we have for news this week?
Kick us off. I'll take it for you.
Okay. There's a few that I haven't put in the show notes yet, but they were all come under the category of static web apps. They released a spate of updates this week. One of them is they
I saw
now,
that.
there are things like this have support for GitLab and Bitbucket. They've got support for stable URLs in the preview environments. You can now skip API builds. As part of if you only want to update the web app and not the APIs, you could skip that. And it also supports Node.js 18. So a lot of updates in the static web app space.
Nice. Kendall?
Yeah, I was actually going to touch on that a little bit too. I know this is not one of the updates that just got announced, but you can actually, from a container app side, you can actually have container apps be the backend for your static web app. That's something that's just worth calling out because I don't think that's been there for too long. So instead of using something like an Azure function, you can do like a bring your own container app. So that's just something I played around with recently. I also saw that there's a GA for cost recommendations for VMSS or virtual
I
machine
saw that, yeah.
services. Yeah, so I think that's nice just because cost optimization is something that I feel like Azure has, notoriously gotten more requests for, right? How do I see the use case, like the usage of my different resources? How can I cost optimize? That's obviously top of mind for a lot of customers. So the fact that now Azure Advisor will essentially say, hey, like we see that this VMSS is basically like not even being used at all, or is potentially underutilized. So I think anything we're doing to help customers get better utilization of the hardware they're paying for within Azure, I think is a great step in the right direction. So
Yeah, I think that one I thought was really good because I know there's been a bunch of efforts. Abhishek, you've probably been directly involved in some of this because you run some services, but we periodically do this kind of scrubbing in our internal environment as well. And let's just say we're not always as efficient with our resources that we're consuming as we can be, and that costs money, but it also consumes resources that we could be turning around and providing to our customers. So that striking that balance is always important, right? So having the capabilities to do that.
That that is true, and then there are always like the demand for Azure, though it's like Azure is like consider people like our customer consider as an infinite pool of resources, but at the end like with the so much growth, it's
Yeah,
always gets constrained on one or the other resources. So it's a good idea not only to like it's a win-win for the customer and for Azure.
absolutely, absolutely. Yeah, at the end of the day, although we're not going to quote the number here, there is a specific number of servers that live in underneath Azure. Yeah, the couple ones that I wanted to call out, the one of them, and I hadn't even thought about this as being important until I saw this, but Azure Automation now supports availability zones for your running. Because again, people rely on these automation tasks to run to keep their business up and running. If we have a problem that takes down a zone, those things need to keep running. Also, the Azure multi-factor authentication, so MFA server. So this is the on-premises version. This is not the Azure Active Directory version. This it's been sort of in the works for a little while. We've been bringing feature parity to Azure Active Directory MFA, but we've actually announced publicly that in September of 2024, the on-premises version will be deprecated. That's a pretty big step if you think about it, right? That we're completely removing the on-premises for even our Exchange and SQL, right? There's still an on-premises version. It really sort of indicates how far AAD has come. And then the last one I wanted to mention, and again, this was not planned. This is right up Abhishek's alley, but the default rule set 2.1 for Azure Web Application Firewall went GA not too long ago. And this is huge because and again, you can talk about it in depth if you want, but basically my understanding is we've completely rebuilt the engine for this. And this brings a ton of extra performance while also bringing in, the new rule set at the same time. So it's a great benefit for customers. You should definitely look at adopting this.
Absolutely. This is we released on Edge, and then there is another announcement which I love it as we released the self migration tool from the classic AFD and CDN SKU to the AFDX SKU with zero downtime. So if you are a customer that are using the classic AFD or Microsoft CDN SKU, and then you want to migrate your application that are onboarded on those SKUs to the new AFDX Premium or Standard, it's a general available migration tool with zero downtime for your application.
Yeah, that's great. Now is that when you talk classic in this case, is that the traditional, when we talk about classic web, classic cloud
Classic Azure,
services and whatnot?
yeah, a classic Azure front door. Before we merged, we had like separate like SKU for the
Gotcha. Okay.
acceleration and separate for the content caching, and then we released AFDX with bunch of new features like private link enabled and then many of the security and other functionalities. But customers were concerned how to migrate from
Yep.
this to the new one. So now it's
Okay.
available.
Awesome. Zero downtime is good, right?
Yes.
Yeah. So okay, so with that, let's transition over to Abhishek. So Abhishek, you've been on the show before, talked about a bunch of different networking things. We were chatting on the side, and you offered to come back to talk about, edge security and layer 7 security. What do you mean by that? Let's sort of maybe define those to start, just because not everybody talks network layers. So let's define that stuff to start. What do we mean by edge and layer 7?
Yeah, and I'll start take like in a step back, and this is my own experience and learning in Azure Front Door, which is like a global service we talked about in previous episode, runs on the edge, distributed across multiple POPs, more than 200 edge sites across the world, and there are two things when it comes to the security part of it. Um, some of the vulnerability that you have in your software, hardware, firmware combination that gets exploited, that's more like a sort of security attack or exploit. The other one is like a little bit brutal, which is like denial of service. So then like yes, we don't know your vulnerability, but we will like try to take you offline either by brute force or like
It's just flooding you with packets,
yeah.
basically.
So this is the precise point when like when we talk about denial of service, it like in the first thing it comes mind like flooding with packets and then flooding with your network, and then like and usually network has much more capacity than the servers, application servers, and then backends, and then if it's not stopped at the right point, most likely you're gonna take down your application servers, backend servers, and that kind of attack at the packet level, which is we call it L3, L4 network DDoS attack. Um, and Microsoft provides the one DDoS solution for it. You can onboard, and then it would protect from these volumetric network level attack. The challenge with the edge and then the edge security becomes a bit challenging in some of those scenarios. And I'll talk about two categories. First, on the network level attack. What happens with the edge when customers onboard to edge promises on certain functionality to them. A, it promises the acceleration. B, it promises the cost reduction by not taking your traffic to the data center or other location because of the cached content, and it's being served very cheaply.
Reducing basically your compute and whatnot, resource consumption at that point.
And then third is the providing you the security, not having some malicious attack and exploits coming to the end. So those are the three. The challenge with the volumetric attack, typical volumetric attack network level is if you take if you detect the attack, and then if you take that traffic somewhere else to scrub, and then like you do a good job, scrub all the malicious, the attack traffic, and then send it back, you have already caused a challenge to edge. And it works beautifully for Azure because you are in the same data center. The traffic was supposed to go to the data center for your workload applications, and then right there you get a scrub, and then when it's released, it's there very close to the where you are running your applications. But in our scenario, if you take this traffic from the edge side to even a nearest data center location, you have taken some penalty on the latency. And when you release that traffic, then you have caused the traffic concentration problem, because these were the distributed user traffic that's supposed to go on the nearby 3, 4, 5 edge sites. And now you have funnel that entire traffic to a close by data center. And when it leaves, it's just going to find a very nearby site. And good chance, very likelihood it just gonna find one site that's the best in terms of latency and performance. So you'll cause the traffic concentration problem, you'll cause the latency problem, and you cost the violates your principle of cogs as well, because the sites that were supposed to be caching your content, now you send it to the data center chooses some other sites which is not cached
Oh,
content,
it
and
goes
it's
somewhere else you don't think.
somewhere
Yeah.
else right there. So
Yeah.
it poses a different set of challenges, and this is the learning on the network level DDoS attack. When you run on edge, you have to be, in last episode, edge, the line I use, the data center is big swimming pool. People jump in, they spill some drops, it's okay. Edge is a small cup. You spill something, everyone would notice. It's a very expensive, probably single malt scotch, few drops, and then you notice, oh my God. So that's on the volumetric side of it. But and then we have been working with our 1DDoS team to have a homegrown solution that runs inline. You don't have to take that funnel traffic to some other hardware or the devices that would do. It's our homegrown solution, DPDK, all sorts of the acceleration available today, and that would do this scrubbing inline at the edge site itself, not even causing you more than 1 millisecond latency and not taking your traffic anywhere else. So that's the first thing we have to do, and it's a deep stack and investment that we have been working it for past 1.5 years, and this is the time when it's being in the production. Then the second learning is in 2 years back, if you could ask, if you ask, where I'm losing my sleep, I would say these volumetric attack, and that's what it is. And I have to do this inline, the in home built inbuilt solution to put in, and once I'm there, I can sleep peacefully. But turn out that's not the case. These attacks are getting more and more
More
sophisticated.
aggressive.
Denial of
Yeah.
service,
Smarter.
yes, and
Yeah.
and smarter, and they are progressing on to being volumetric on the L3, L4 side, being volumetric onto the application layer side. So they are still volumetric, or volumetric, I say, is they are not exploiting a particular vulnerability, but they just want to keep it minimum enough to cause you damage. That's so it not necessarily.
The one scenario I've seen is where I saw one at one time where somebody used they set a whole bunch of SSL traffic, and the site that they were sending it to, that this wasn't even in the
Yep,
cloud, but the site that they were on had it just had a hard time processing and
yep,
managing all
yep,
these
yep,
SSL connections.
yep,
Right? That
yep.
is that sort of what you're talking about?
That's one of the very basic L7 attack you could have. So what
Mhm.
they do is they'll do a volumetric L3 L4 attack. They see what's the threshold limit where DDoS solution would start
Mhm.
rejecting you. So there's
Oh,
they
because
they
they can
figure
go lower.
they, yeah. So they
Oh,
know, oh, okay, you're probably you allow 5,000 flows or
yeah.
10,000 flows, right? On the network layer, but that's not the application capacity
Yeah.
is, right? And then boom, then they have these
They
10,000
said just
SSL,
under that.
they're just under this. So they'll bypass all the things and then attack on the volume. And then challenge with if you see on the SSL application protection, you have to terminate these connections and then you can do whatever you want to do, whether you want to rate limit, drop, or throttle, right? But it's very expensive to do it after termination, because that's where you go from the lowest kernel mode
Mhm.
to the user mode side of it, spend much of your CPU cycles there. So even though you do a good job at that layer, you have cost damage to yourself. You might be able to somehow survive, but that single thing doesn't work. So, and what you see is the L7 protection, unlike the volumetric network protection, it's a multiple layers of protection you have to put in, and it's like a Swiss cheese model.
Mhm.
Like even on the L7, you have few comment, then like then the next layer would like the rest, and then rest, and then rest. That's how it works. And again, it's a homegrown solution in Azure Front Door. We have three different layers, uh, that protect us from the L7 attacks. Ivan, you
Do
have your
it
hands
is it, yeah. So do as a so I spin it with Azure, not the Azure podcast site. So we have
raised.
our site, right? We want to protect against this kind of stuff.
Yeah,
We're not using AFD today,
right.
but let's say we turn on AFD. Do I need to turn on additional features to get the layer 7 DDoS that you're talking about? Does this sort of come with just enabling AFD? Like how does it look like for me as a customer to take advantage of this?
So there are two parts of it. When the L7 DDoS attack happens, it's like, by the nature of AFD, the attack would come to the platform first, right?
Yep.
Because we are the one terminating it. And then the good piece is we are keeping this persistent connection to your applications, in this case, to your podcast server. So a attack would come first on the platform, but AFD platform is large, right? So it can, like, say your server could handle like, maybe 1,000 requests. We can like absorb million, and we might not even react with a million flood. But if I forward that million to you, you would get impacted.
Yeah.
The reason I'm saying is, so it's two. So these 3 or 4 layers that I talk about, this is for the platform, where like,
Okay.
I'll ensure that I will not like, have this platform get impacted with this. Once I have protected the platform with enough capacity, then I can protect the customers behind it. So in this
Mhm.
case, when you onboard to the Azure front door, you can use the one that you talked about, the web application firewall, and you can set, hey, my backend has this capacity, these many requests globally I want to take on this location region. I want to take this, like,
Mhm.
all threshold that you would define in typical network level DDoS, you can define it here onto the application side. And what Azure Front Door would ensure that, like, it's edge, it's anything that is crossing the threshold is right there at the edge. You just not see this, neither on your network layer nor your application layer, anywhere. Those server will not see any of those aspects. But you have to turn on specific WAF rules to
Okay. So I
make
do
sure
need to turn it
to
on to get the
to
advantage
turn
of it.
it
Okay.
on to advantage, because we will not know what's your server actual capacity is when you configure, right? So you better know it. You could be conservative. We suggest people to have, like, whatever the peak they expect,
Mhm.
and then have, like, the, bit above threshold from the peak, and then you can always fine tune it. We have the Whenever we take any action, we will, like, log it, inform, like, by our metrics, so the customer would know whether the DDoS protection was kicked in for
Mm.
their
Okay.
traffic or not, and then fine tune
Okay.
it. Yeah, we talk about, like, we had a very candid conversation with all Azure customers when we talked about our September 7th L7 DDoS live site as well, even. And some of these the attackers, like, I'm not going to talk about all, but, like, few of the tricks is even at the application layer, the protocol allows you to have negotiated one TLS or SSL session. So you, like, from even to your application server side, it's just one SSL connection that's terminating, but protocol allows you to send multiple HTTP sessions on that single
Within that.
TLS,
Yeah.
within the TLS. So technically, you could still have one connection and then can flood thousands of HTTP new sessions and new requests underneath that. We have seen that kind of attack. We have seen different exploits, like taking the longest path, hogging the resources, where you send a request to download, like, 100 GB of file, but server is sending byte by byte, keeping that connection
Yeah.
on for, and then
Yeah.
exhausting all your resources. So it's they are evolving, attackers upping up their game, and then we are upping up our game, and this is going to be journey. It's That's the way it is. um, yeah. um, we are very like we had some hard learnings, and then I'm really proud of some of the investments that we did. We talked about like we discussed this with, by the way, with some of the industry experts as well, like on the are we on the right track or not, given like Azure front door is still kind of newer compared to the Amazon CloudFront and others. Hey Kendall, you have your
Yeah,
hands
yeah.
raised. Yeah.
Yeah, so I don't want to take us too far down like this path, but just as someone with a little bit, just with a little bit less familiarity, I know I wasn't on the last show, but I mean, I definitely think this makes sense, right? Getting that layer 7 DDoS protection and being able to run at the edge. And I know that Azure Front Door is a globally distributed service that really focuses on that, like, front door protection, which the name is fitting. But I'm curious, like, I see some recommendations and even some customers, right, who make use to some extent of also app gateway,
Yeah.
like at a regional level. And so I'm just kind of curious, like when you're adding these capabilities from a front end perspective to Azure Front Door, what is that like? What kind of scenarios do you see where app gateway still comes into play, and how do we make sure that those two services are coordinated, especially when we talk about application layer? Well, what if the application layer is 3 layers away instead of just like, sitting behind the Azure front door, just out of curiosity? And I'm getting a lot of questions around this just with how do we architect solutions, in front of container apps. And yeah, so it's a selfish question as well.
Oh
And
yeah,
then,
yeah. We talked about this in the when we
okay.
were discussing the Azure front door. But to answer, application gateway also provides the pretty much similar web application firewall capability. Application gateway is a regional application load balancer. It's not about content caching, that cost reduction. It's not about the acceleration. It's very much about the load balancing of your application backends and protecting your application backends with the web application firewall. So to protect the customers, you could configure the same WAF policies on the application gateway if your application scenario, which is like a regional load balancer inside the VNet, is requiring an application gateway. Application gateway also being in the Azure data center and in your VNet doesn't have the L3 L4 volumetric attack challenge where traffic gets shifted away somewhere. So customers could simply application gateway, by the way, it by default leverages the 1 DDoS, and then customer on their backend could also leverage the 1 DDoS for their network volumetric network DDoS attack. So that's the subtle difference. Whereas on the edge, you have to be in line, you have to provide some of those protections bit differently. But otherwise, it's the functional device. Our customers, whether they use application gateway or Azure front door, they are secure. The similar functionalities are there. When to use application gateway, when to use Azure front door, or when to have
Or even,
integrated
yeah,
app.
like, or
Yeah,
even like when they're used together, right? Because you
together
might
to
want that
right. Yes.
edge
Yep.
presence while also, yeah.
Absolutely. And then when you use together, then then the Azure front door would be the first layer, and that would ensure that even application gateway, which is the backend for the Azure front door, does not even get the volumetric attack to the application gateway. And then there you can define your protection policy somewhat more in detail to the application backend. So application gateway, for example, would have far more knowledge on your Kubernetes pods, the VMS as individual VM instances, and then can have policies pretty much uh, a one step deeper than the Azure front door in those scenarios. So that's how one should see.
I think that, I mean, these days, those are the WAF for AFD and WAF for front door. That's all one happy team these
One
days,
happy,
right?
yeah,
So
yeah. It's
yeah,
a one common user experience. So it's the feature release might be a bit like have a lag one way or versus the other,
yeah,
but yes,
yeah.
the experience is the common experience.
So taking this in a slightly different direction, you had been on the show before and talked about work we were doing in DNS and the dual stack that we've got there to increase the resiliency. Talk about some of the security changes that we're doing at the DNS layer. DNS security is a thing you have to worry about these days.
Yeah, so DNS again, Azure front door platform, we have to be careful on the DNS security as well. DNS is also one of the most attacked platforms, because once you take down DNS, you are
Nothing
successful.
else works.
Yeah. So from the get go, more than the volumetric attack, DNS application attack was known phenomena, I would say, and that's where we have again a very specific layer for our DNS. We call it internal code name Kevlar, that protects against the DNS exploits. You could get it, like, tricking out on the NX domains, scanning
Mm.
of, like, and then creating a choking on a particular point. So that's what the DNS does. But um, DNS is also shifting into a bit different direction. I'll touch Ivan on this piece. We are asking our customers to be like, if they are deploying in Azure in the virtual networks, we want them to be private enabled. It's a completely isolated from the internet. So then you are not directly exploitable. So once you have this in the complete isolated workload deployed, DNS was the one that was left out open, so to say. So
Mhm.
there is a private DNS resolver. We recently went GA with the private DNS resolver. That's a part where it works beautifully if you have a lockdown on-premise, which is a complete private address space, and then you have a virtual network with private link enabled, which is also a private address space. And then you need these two islands to work together, and DNS was a bit of a friction in those two islands, because our private DNS authoritative would know the namespace of VNets, but then the on-premise would have, like, when they want to bring up their own custom names, would have challenges. Vice versa, when these VNets needs to talk to the on-premise namespace, they will not have the, like, ability to do. They could go to the private DNS, or they could go to the public authoritative service, but they could not have an ability to talk to those private DNS resolver by the customer who might, like, already having it deployed in their on-premise. So private DNS resolver is a multi-tenant PaaS platform. You don't have to manage or do anything, basically a dedicated for your VNets or for your deployment, but you can onboard to a private DNS resolver service. Consider that as a conditional forward, the condition that you define, a security
Mhm.
condition that you define, and based on those security condition, it will ensure that the namespace that you are, like, targeting, those are the only ones reached out on the private address space. The rest is on the public address space, or you can restrict to the public address space either. So it's not directly security, but it, like, it basically allows you to go more secure manner with the complete isolated workload deployment between on-premises and virtual
Let
networks.
you put this ring around your deployment, right? And say, I don't really want traffic going in or out at this
Right,
point
right,
unless I
right.
want it to.
Yep.
Okay.
And there are lots of exploits happening with the DNS, which is, like, in your application workload, doing the scan of the the NX domains, and then, like, figuring it out what kind of domains you might have had
Mhm.
it. That the risk with that is, um, when you deploy your application, like, say, I'm just picking a name, like, you might have an application bing.com, and bing.com is, say, that's the host name that, users would connect to, but underneath on that application stack, you might have something xyz dot co dot something, which is like your internal service or your partners are talking
Mhm.
to, right? And unfortunately, those becomes still, like, some publicly accessible thing, and API surface, and you, as a customer or application owner, not always design those weak aspects to be as scalable as bing.com. It's a nature of it, like, you put more focus on bing.com and that's left behind, and then one could simply scan and figure it out. These are the domains you, like, or subdomains you are serving and supporting, and then they can target your, like, attack to your weak link. So DNS is coming in and, like, like soon, like, almost all the DNS providers are thinking in that direction, where they are slowly restricting these kind of scans, like, the any deviation on your name resolution pattern by your workloads or by your users to see there is an exploit or someone knowingly trying to exploit you. So that kind of information is very helpful, because that's you would get it much before when the actual attack happens, because once they figure it out, your weakling or exploit, that's
You're
when the actual
toast at
attack.
that point.
It's
Yeah.
your test. Yeah. So
Yeah, Abhishek, I was wondering as an application developer, if there's any things I need to worry about. You just talked about the DNS scanning option, but going back to the original protection that you offer at the edge,
mm,
are there any things that an application could be doing now that could be blocked, let's say, right, by these new security rules, and it might not reach the application? It's something that the application didn't know that that pattern or path was being used, right? But now all of a sudden it's going to stop working, right? Because you turned on that feature in AFD, and suddenly, like, a handful of calls and that's just not coming through. Uh, I guess,
It's an app
I'm
problem,
just
Sujit. It
I
definitely
know
is your
it's
app.
always an app problem, right? But I'm trying to figure out, like, how does one detect those kind of situations? Yeah, of course, can they happen? How do they detect them? And then what's the kind of reporting so you could go and figure out, hey, this is, my app didn't get these requests because of such and such problem.
yeah, you are right, Sujit. It's not like, as even application as an application developer, there would be some very common sense basic known things that you would know, and then, like, you would be very confident when deploying those policies on Azure front door. There would be some other policies which you feel like, are needed but not very sure. As you said, it could block like genuine traffic or do something. There are things like, the when you deploy these policies in Azure front door, you can always start with the detection mode versus in the prevention mode. So you deploy in detection mode, you get like and say, hey, you are hitting, by the way, and then you can decide, like, once you put in the prevention mode, it's gonna block it, right? Like, so those are the, like, somewhere, like, that's how, like, you could, like, it's like SDP of your
Yeah,
policies, right?
absolutely.
So start on those ladders, and then of course, whether it's a prevention mode or detection mode, we would be providing the metrics and then logs whenever our layer is taking that decision. And then again, we provide certain logs, and it's a journey. Like, we are, like, in the Zinc milestone, we would be adding more and more such metrics for you as an application developer to have a complete insight of, like, what's happening. One example is, like, your backend health in the classic Azure front door SKU. Like, if your backend health, like, it's completely down, then I'll say your backend is down. But now we provide metrics when we send in health probes. What's the typical success rate I see on your health probes? That's a metric, very useful metrics, because you might be having a period of stress on your application backends and then not responding, but majority time you are okay. That kind of insight is, like, it's much needed. So this is just an example of, like, how we, like, intend to, like, have more and more such insights.
I think when I hear you talk about these features and capabilities, these seem to me to be sort of really great examples of things that when we implement them at the platform layer, one, just to Jeet's point, I mean, there are certainly scenarios where you might block yourself unintentionally, but as a general rule, you as the app developer shouldn't have to care too much about, DDoS. It's sort of below your layer generally,
Right.
except when it's not, right?
Right.
But those are, the bad actors that are out there doing this are continually finding new scenarios, and if you were trying to own and manage this yourself, you drive
Right.
yourself crazy chasing
Right.
these.
Yep. Yep.
Right. And so by doing this at the platform level, it really says, you know what, in this case, Microsoft, right? Certainly other cloud providers as well. Microsoft, just I'm gonna trust you to stay ahead of, or at least
Yep.
equal to the bad actors out there. And I'm just gonna turn it on, let you, and I'm gonna tell you my rate limiting and let you protect me versus, and then I can spend my time on
Yep.
my app or my
Yep.
functionality instead of trying to just protect myself at a bare level.
Yep. You are right. And then this is, and as a platform, not just on the policies, but my goal is to understand your traffic pattern, where I don't have to like literally ask you what's your peak is and then what's those thresholds should be. I should be the one like, recommending, hey, based on like, your pattern on 30 days, that seems to be like reasonable policy. And is that something like you can play with? So it's not like, completely in dark or like,
Yeah.
a full exercise you would do. But you are right, like, doing doing protection at edge and then front door level. And then when Microsoft is thinking about these things, because Microsoft has a reputation to protect as well, because it needs to protect the platform, right? So,
Yep.
yeah, we would be on constant journey to be evolving our platform to make sure both of us are protected.
And Abhishek, just in the interest of being transparent here, what are the cost implications of turning this feature on i- in AFT?
It's not. So it's a bundle with, if you are getting the WAF policies enabled, for example, if you are a AFD standard and premium SKU, getting protected right now on these specific things, it does not cost anything extra. It's just the same security bundle that you have opted in. And we are cognizant of the fact that, like, yeah,
Yeah.
Yeah.
we want to make
Nobody,
sure
no,
it's a reasonable.
nobody wants to pay for it until they're down, and then they wish they had paid for it. So making that cost net, an additional zero
Right,
is it makes my life easier. That's for
right,
sure.
right. Yeah.
Yeah. Well, no, this is great. Abhishek, any last things that you want to leave the audience with on this? I mean, I think we covered a wide range of capabilities that exist at layer 7, and I think it's a great feature set for customers. Any last thoughts you want to leave the audience with?
Yes, I mean, like, this the world is changing. Like, in last 2 years, what, like, the security attacks and exploits used to be some of the infrequent, rare
Hmm.
things, are like super super common. You don't hear it
Hmm.
from Microsoft and on your backends, but it's like constantly happening. So what my thoughts are, you as a customer or application developer or owner, you need to plan for the security and then security architecture of your application from the get-go. And this is the, like, keep do not open the door or the surface area if you don't need to. So, like, Microsoft, like, a recommendation on the private link, making sure, like, your internet facing is protected by Azure front door, or
Hmm.
if it's a regional site, it's application gateway. You are, like, getting into the 1 DDoS policies of the Azure and Microsoft. Those are the recommendation. I encourage everyone to take a look, because it's not that you are in the some side of segment that's not, like, the in the attention of those attackers and hackers. It's they are attacking everything and anything.
It's ironic. We were actually talking amongst ourselves as hosts the other day. It looks like somebody did try and launch a volumetric attack against there's a storage account we use for some of our work, which showed up
Exactly.
in the telemetry. And what was awesome is everything seemed to just keep working, right? So we didn't even have to worry about it
Right.
from that side. But yeah, it like you never know who wants to attack the Azure podcast, right? Everybody loves
Yes.
us.
Right.
But it just
Well,
it can happen.
yeah, and we talked about it in the previous episode on the Ignite update that Mark Russinovich announced, the Azure Innovations. There was a number that he had announced: 1.29 quintillion security events were
Yeah,
detected in Azure last year.
yeah,
That's a huge number. I know that.
Oh my
yeah,
God. Yeah.
yeah,
I
yeah,
know that we like also were like wrapping up the topic, but I do have one more question now that I'm just thinking about it, right? When I set up Azure Front Door as the entry point for my backend, can I make sure and force all of that ingress through Azure Front Door, right? Like I can make sure that the exclusive ingress pass through depends on Azure Front Door so that there's no sort of like, hey, some traffic goes through Azure Front Door, but you could route around it in a VNet, for example. Like, is that true?
That is true. If you want to, what, like, so the if you put, like, onboard your domain, and then if, like, whoever trying to access through the domain, it's always go, like, through the front door. But the mistake that one could make, like, you could still have a public IPs on your application server, which is accessible over internet. And then, even though application traffic is direct, someone could directly attack your IP. So front door won't be able to protect it. And that's where the recommendation, like you want to lock down your if it has to be internet, then lock down with the service tag of front door, so only front door IPs are able to talk to your application backends, or lock down that application backend to be private link. And then Azure front door has this feature of integrating with your private endpoint, so it's not even available or accessible from the internet.
Okay, cool. Thanks for the confirmation.
Awesome. Well, great. Well, Abhishek, thank you again for coming on. As always, great to have you. We'll look forward to having you on again in the future.
Thank you. Thank you.
Thanks,
Pleasure
folks.
is mine.
Thank you.